Hello. So today I'll be teaching Algebra 1. I'll be teaching from lesson 64. Page 418, it's identifying, writing, and graphing inverse variations. So make sure you turn your books to page 418, lesson 64. I would recommend you having the book in front of you and also making sure you're seeing me while I'm teaching, and also have the worksheet in hand. Before you take the quiz, I recommend you doing the worksheet before you take the quiz so you get an idea of what's going on. For today's homework, it's just lesson practice. So it's gonna look like this. It's about 5 problems, so this shouldn't take too long. But if you need additional help, continue along with this video. So before we learned about direct variations, y equals kx, where k is the constant over here. Remember, the equations would normally be like varies directly. They use that word. But now today we're gonna know a new word called inverse variation. So the inverse is like the opposite. So whenever you see word problems, they'll say, the key word here is vary inversely with x. So again, you need a constant, but now it's y equals constant divided by whatever x is. So here also keep in mind the product rule for inverse when you're dealing with 2 different types for y, 2 different types of values for x. So here we have x and y, x times y is equal to x, the second x times the second y. So now for example 1, according to your book it says, tell whether each relationship is an inverse variation and explain. So you have 2 options, direct variation, inverse variation. So for number 1, all they want you to do is just to figure out if it's a direct variation or inverse. So if it looks like one of these 2 or it's neither. So to do that, for example 1a here, all you have to do is get y by itself. So you're solving for y. Solve for y to find which type. So here example 1a, you have y over 6 divided by x. To get the y by itself, you have to do the opposite operation. In this case, 6 is dividing into y, so therefore I'm multiplying both sides by 6. That cancels that out, the y is by itself, and I get y is equal to 6x. Now, that's not it. We have to figure out, is it a direct or inverse variation? So according to these formulas, when you got y by itself, you have a direct variation. It says tells y, but you're just solving, saying which one. Your work is already telling why it is a direct variation. Second one, x times y equals 5. Again, you're solving for y to find out which type of variation it is. So here, to get y by itself, you divide both sides by x. It's xy. When they're next to each other, that means they are multiplying. So therefore, you divide the 2, and you have y is equal to 5 over x. So looking over here, to figure out which one it is, just look and see which one it fits into the pattern. So according to this, inverse variation, it fits into that pattern. Inverse variation. Your work is explaining why. So that's for example 1. So you're gonna apply that rule to the lesson practice. Example 2 is using the product rule. That means you have 2 values for x, 2 values for y. So example 2, if you read it, it says if x1, y1 and x2, y2 are solutions of an inverse variation, then you have this equation here. But example 2 says if y varies inversely, that's the key word, inversely. So if y varies inversely as x, that means you're going to use the inverse variation equation. So again, keyword inversely. So it's direct or it's inverse. Here it says if y varies inversely as x and y is equal to 3 when x is 12. So that's the first part. The second part is, what is x when y is 9? So you have your first set of x and y coordinates, you have your second set of x and y coordinates, now you have to go ahead and figure it out. So the key word was inversely. For direct variations, we made proportions. So remember, we had one fraction equal sign, the other fraction. So in this case here, you have inverse variations, so therefore you're applying the product rule. So meaning, the first set of coordinates, you're multiplying them. You're setting it equal to the second set. So here, according to this, y1, x1. So when y equals 3, y equals 3 when x equals 12. So that means that's your first one. So the first one is 12 times 3. When y equals 3, x is 12. So that's your first set of coordinates, if you want to see it like that. Here it says, find x when y equals 9. So that means we don't have our second x, but we have our second y, which is 9. So we have 12 times 3 is equal to x, the second x, times 9. So according to this, we multiply it out. And this is not an exponent, it just means the second x. So that means to get the x by itself, to solve for it, you simply divide. The reason why you divide is because they're multiplying. So you go ahead, cross them out. 36 divided by 9. In this case, you have 4. So that would be all of it to find your second x. So again, it's not proportions because it's inverse variation, deals with the word inversely. So example 3, we're gonna go ahead and wrap it up. Example 3 just talks about graphing and inverse variation. So in this case here, it says write an inverse variation relating x and y. Go ahead and erase all this. So it says here, write an inverse variation relating x and y when x equals y equals 8 and x equals 3. Then graph the relation. So that means we need to find an equation that fits into y equals k over x. The thing is, with this equation, we don't have what k is. They give us what x is and what y is, but we don't need that. We need to find k. So that means to find k, we have to use what we got. We got y is equal to 8, x is equal to 3. So go ahead and plug it into the equation. 8 is equal to k divided by 3. Get the k by itself. You're going to multiply both sides by 3. So then you have 24 is equal to k. But that's not all. What you're trying to do is, again, you're trying to get this format right here, this formula to graph your equations. So here, when you're looking over here, you go ahead and plug in what k is. And you're not trying to put in the numbers for 8 or 3 for x and y, because all you're simply doing, if you can see it, there you go, is just trying to get the equation. So as soon as you get the equation, as soon as you get the equation, you go ahead and leave it there, and then you're good.